This is a nice standard trigonometry Rcosx+a question. As usual, we're going to be finding the value of r and the value of a, or alpha in this case, and then using it to solve some sort of equation, using this nice harmonic form it's called. So what do we need to look out for? We need r to be exact. We need alpha to be in radians to 3 decimal places. We need c that pops out here to be positive, otherwise we've gone wrong. And then when we solve this equation, we need 2 decimal places for our answers, and our answers should be between 0 and pi. So these are all things we're going to go through and check at the end. We can also check our answers, by the way, which we'll talk through. So anything else to point out? I don't think so. Let's talk about this equation then. So 5 cot 2x minus 3 cosec 2x equals 2 has already been manipulated in part B down to here. So solving this equation is the same as solving this equation. This equation on the left-hand side has 5 cos 2x minus 2 sine 2x. And here we have 5 cos theta minus 2 sine theta being written in its harmonic form, r cos theta plus alpha. So the only difference between this and this is that theta is 2x. And therefore I can rewrite this left-hand side as r cos, not a theta, theta's changed to 2x plus alpha. So this is going to be really super easy to solve in part C. Nice, easy 4 marks. How can we check our answers in this one? Well, when we're solving an equation, an obvious check that we can do is to sub the answers back in and see if they work. This one is a show that, and we're going to get a positive constant here, so that we'll know that that one's worked. And this one is a really good idea to check this one, because a mistake here is going to cost accuracy marks here. So this is easy to check. If you are right that 5 cos theta minus 2 sine alpha is indeed equal to your r cos theta plus your alpha, then if you sub in some theta here, I usually use 2.5, don't ask me why, I do not know, and get an answer, then it should be exactly the same, or at least, okay, not exactly, because we've only got alpha to 3 decimal places, but it should be very, very, very close to what we get if we put the same theta in here. So by checking the accuracy of our part A, we're making it much more likely that we're going to get accuracy down here, and then we can check the accuracy here as well by just putting our answers back in and just seeing if they work.